Welcome to the continuation of test 2 review. We are going to continue from where we left off the other time. And so in this problem, we are told that Sally's hair has, there are three hairstylists, and those hairstylists are Chris, Karen, and then Amy. What we are being asked here is to use the tree diagram to find the indicated probability. And then we've been given certain information, and then we are asked to find what percentage of unhappy customers had their hair cut by Amy. So let's start. We are told that 23% of the haircuts are done by Chris. So let's try to represent that on the tree diagram. So, right. And so this is Chris 0.23. And then 36% are done by Karen. So let's say this is Karen 0.36. And then 41% are done by Amy. This is Amy. And then this is 0.41. And then we are told that Chris finds that when he does haircuts, 7% of the customers are not satisfied. So so let's do here satisfied, let's do here not satisfied. And we are told that 7% are not satisfied. So 0.07. If 7% are not satisfied, it means that 93% are satisfied. So 0.93. Yeah. And then Karen also finds that when she does haircut, 4% of the customers are not satisfied. So for Karen, satisfied, not satisfied. So for Karen, 4% are not satisfied. 0.04. It means that 96% are satisfied. 0.96. And then Amy finds that when she does haircut, 7% of the customers are not satisfied. So for Amy, this is for Amy, satisfied, not satisfied. And so we can see that here would also be 0.93, and then here will be 0.07. So this is how to represent this information on the tree diagram. And then we are asked to find what percentage of unhappy customers had their haircuts by Amy. So for the first thing we want to find is what is the percentage of unhappy customers. So to be able to do that, so we are going to find you're unhappy given that your hair is done by Chris, your hair is done by Amy, your hair is done by Karen. So to do that, we are going to multiply 0.23 plus times 0.07. So it means that here would be 0.23 times 0.07, and then that gives us 0.0161. So we are just focusing on the not satisfied. So you are not satisfied given that your hair was done by Karen, you are going to get 0.36 times 0.04. So you can use your calculators to do that. Let me try to do that here. So that is 0.0144. And then the same thing here. You're not satisfied given that your hair was done by Amy is 0.41 times 0.07. And then that should also give you 0.028. So it means that the probability of unhappy customer, so which is P of U, is equal to 0.0161 plus 0.0144 plus 0.0287. This is 287. And so probability of unhappy customer gives us 0.0592. And we are asked to find what percentage of unhappy customers had their hair cut by Amy. So probability you had your hair cut by Amy, given that your unhappy customer is equal to probability of what? Or you could even use not satisfied, it's the same thing. Or unhappy, not satisfied, unhappy is the same thing. So Amy and not satisfied or unhappy is the same thing. Divided the probability of you. Let me just maintain this thing here. Let me just use you. And so that gives us, so you are unhappy or not satisfied, and then your haircut was done by Amy is here. 0.0287 divided by probability of your unhappy customer, 0.0592. And so when you divide the two, you are going to get 48.5% or 0.485, which is C. Okay, now let's proceed. Here, we are asked to create a probability model for the random variable. You pick a card from a deck. The question is that if you get a face card, you win $10. If you get an ace, you win $25 plus an extra 50 for the ace of hearts. For any other card, you win nothing. Create a probability. How do we create a probability model? So when we look at this one here, we can follow what we have been given here. So let's create our table. Let's create amount 1. We are told that you could win 10. You could also win 25. And then you could also win 75 if you pick an ace and then the ace is ace of hearts. It means they are going to get 75. And so you could also get 75. Or you could get nothing. For example, how do you get nothing if you pick, say, maybe spades, but it's 2? That is not a face card. So you're going to get nothing. And then let's put the probability of amount 1. Let's begin to do the easy one. We are told that if you get a face card, you win 10. And so what we've already talked about this. Face cards are what? Jack, Queen, and then King. And so you have all these 3 for spades, all these 3 for clubs, all these 3 for ace of hearts, and then the other one. So it means that we have 12 of them in total. So the probability of going to get $10 is going to be 12 over 52. So we've done that one. Now, let's proceed. If you get an ace, you win $25 plus an extra 50 if you get ace of hearts. So let's do the ace of hearts first. So what's the probability of you picking an ace of hearts? Ace of hearts is just 1. So that is going to give us 1 over 52. How about if you pick any of the other? Remember, we have 4 aces: ace of hearts, ace of clubs, ace of spades, and ace of diamond. So if you pick ace of hearts, you are getting 75. But if you pick ace of club, ace of diamond, ace of spade, you are getting 25. And so how many are they? There are 3. What's the probability of you getting nothing? It's very easy. Remember, you could sum all these and then everything here should be equal to 1. Or you could also see that you could also count and subtract the a's and then the face cards from them. What will be left? So for example, we know that a's are 4 and then face cards are 12. If you subtract that from that, you are going to get 36 over 52. Or you could do 1 minus 12 over 52 plus 3 over 52 plus 1 over 52. And so that should give you 36 over 52. So here is what 36 divided by 52. So that is how to answer this problem. So here is 36 over 52. And so when we look at our possible answers, we can see that it is this one. Okay. Now let's proceed. So for this one, we are asked to find the standard deviation of the random variable, and then we should round to 2 decimal places. So you just have to look at the formula. Remember, to find the standard deviation, we need the variance. So we know that SD is equal to square root of the variance. How do we get the variance? This is the formula for the variance. And before we get the variance, we need the expected value or the expectation, which is given as this. So to do that, we can do this in Excel, or you could do that by hand, but I usually prefer Excel. So I'll do mine in Excel. You can also do yours by hand. So this is my Excel. I want to put everything here. So X, this is X, this is P of X. Okay. I just put in half 0, 1, 2, 0, 1, 2. And then I also have 0 0.5, 0 0.4, 0 0.1. So remember, to be able to get a standard deviation, I need the expectation first. What's the formula for the expectation? X multiplied by P of X. Okay, I've shown you how to do this in class, so I'll move very fast. So what is the formula for the expectation? It is this times that. So I do equals this times that. And then I just scroll down here. I get that. Okay. And so I come and put here the expectation. So you could do it mu, or you could do it expectation, whatever you want to do it, equals summation of all these. And I hit enter. I get 0.6. Okay. What do I want? I want mu squared, or the expectation squared, because I will need that for the variance. So this is equal to this guy here squared. So I've been able to do that. Now the next thing I need is x squared. X squared. So where are my x's? These are my x's. So this equals squared. And then I drag down, which is this. Now I need x squared multiplying p of x. So this is equal to x squared multiplying p of x. This is p of x here. Okay, you just have to be careful so you don't go do x p of x. It's x squared multiplying p of x. So you do that. This gives you 0. And then I try to drag down. And then that is 0.44. And I need the sum of that. So what is the sum? So sum of x squared p of x. This is equal to sum of all these. So that is that. And so variance equals this minus this. So the variance is 0.44. Standard deviation, SD, equals square root of that. So it's 0.6666. So now let's go check our answer. So there we go. So you see we got 0.666 and that is 0.666. Okay, so that is for that. Now the next thing we want to do is to tackle this. Spend time to read this problem, but I will summarize that information here. So I know it's a random variable s with the mean of this. So it means that I have E of s to be 1 for 100 and then standard deviation to be 150. So standard deviation of s is equal to 150. Based on this, I could say var of s is equal to 150 squared. Okay, now you can use your calculator to find what is 150 squared because we already know this information. So that should give you var of s is equal to 22,500. Good. And then when we proceed to read again, we can see a random variable b. So let me use red for that. So we can see from here E of b, a random variable b. E of b is 16,500. 16,500. And the standard deviation SD of b is 600. Based on this, var of b is equal to 600 squared. So var of b is equal to, what is 600 squared? So you can use your calculator to find that. That is 360,000. So that is var of B. And then here we are giving P to be this. We should find the mean and standard deviation of P. So let's find the mean of P first. So expectation of P is equal to 43 expectation of S minus expectation of B. And so we've learned all this in chapter 14, the various properties of expectation and standard deviation and variance. So expectation of P is equal to 43 times E of X was 1,400 minus E of B, 1,6,500. And so when you use your calculator, you should get, so you can do 43 times 1,400. That is 6,200 minus 1,6,500. So you can see the expectation is what? 43,700. So based on just this answer, we can see that C and E is out. So we can see this guy is out. This guy is also out. Okay. Now let's try to find the variance, because it's better to find the variance and then we find the standard deviation of that. So we want var of P is equal to, what is P? Var of 43S minus B, because that is P. So based on this is the same thing as what? Var of 43S plus var of B. Okay. I'll proceed in this place. So to continue, we can see that var of P is equal to 43 squared variance of S plus variance of B. So we just need to multiply. What is 43 squared? So you can do that on your calculator. 43 squared is 1849. 1849 times var of S. You see, that's why I took the time to do that. 22,500 plus var of B, 360,000. So now let's do this on our calculator. And so I got 419,62500. And so SD is equal to square root of var, which is equal to square root of 419,62500. So when you do that, I got SD to be 6,477.846, which is the same as 6,478. So we can see that is A. So you see how to do problems like this. Okay, let's proceed. This next one wants us to be able to determine which variable is the explanatory or the response variable. And so we already know you need to understand what the response variable is. Response variable is what you are predicting, and then the explanatory variable is those variables that you use to predict the response variable. So when you look at this, you can see that the age is the explanatory variable, and then the response variable is the wrinkles. Okay, so let's proceed. Okay, now here we are given a complete, we are told that give the most complete description of the association. So when we look at this one here, what can we see here? We can see the relationship is what negative. We can see as this is increasing, this is decreasing. So we can see negative relationship. Okay. So if we can see negative, it means that this guy is out. Okay. And then what can we see? We can also see that it is what? Linear, right? So negative, we could also see linear. And then to be able to determine whether it's strong, moderate, so we try to see, let's try to draw a circle in here. Our circle is a bit wide, so we can see this as a moderate. So a negative, moderate, linear association. So that is correct. Let's proceed to the next one. Okay, we are here. Let me take it up a bit. So in this problem, we are told that students collected data from statistics students and then present this way. Students collected data from statistics classes, include their height. Their height is in inches and their weight is in pounds. And for the student height and weight, the correlation is 0.6666. Okay. Suppose the variable weight is recorded in kilograms. So it means that instead of the weight being recorded in pounds, it is now recorded in kilograms. What will be the correlation? We've already been told the correlation is 0.666. Now remember, when we are dealing in this, we are dealing with in this chapter, we learned that correlation has no units. Correlation has no unit, so it doesn't matter the unit. So it means that the correlation is still going to be what? The same. Correlation has no units. So that is what they are trying to test you here. Let's proceed. Okay. Here we are told that use the model to make the appropriate prediction. The relationship between selling price and dollars used for further scores and their age in years is analyzed. And we have been given this. So we should predict the price of an escort that is 2 years. So what do we know? We know that what? The model price is equal to what? 14302 minus 1322 times the age. So if you want to predict the price of an escort that is 2 years old, all we needed to do is to do 14302 minus 1322 times 2. And so let's use our calculator to do that. So 1322 times 2 gives us 264. So that's the same as 14302 minus 2644. So 14302 minus 2644 gives us 11658. And so that is B. We can all see that. Here we are given the model, and then we also given the age to predict. So that is that. Let's proceed. Okay, here we are asked to use the given data to find the equation of the line and then round to three significant figures. So to be able to find this equation, we will need StatCrunch. We will need StatCrunch to be able to do this. So let me try and open my StatCrunch, and then we will do this problem in StatCrunch. Okay, so there we go. This is my StatCrunch. So all I need to do is to enter the figures that I have been given. So I do drop height and then bounce height. So we have 96. And then here is 73, 65, 55, 46, 38, 29, 19, and then 8. Okay, so we have this. When you look at the problem, you can see that bounds is the response variable. So let's get to stats. Let's get to regression, and let's go to simple linear. So what's our x variable? Oh, I think I made a mistake. Let me try to um, delete this row. Delete row, good. And then let me name here drop height. And then let me name here bounce height. Okay, good. So you just have to double check that you enter the right figures. I believe I did. Um, so we go to start regression, simple linear. So the x variable is the drop height. The y variable is the bounce height. I chose this to I chose this to looking at the possible answers because I could see bounds equals that. So that is how come I did that. And then we scroll down and then we choose this one. And then let me try to bring this guy down. Yep. So yeah, we good. So let's do this. So when we compute, we can see from here, even when you look at this one here, it gives us the answer that bounce height equals 0.321. So I'm going to record that here. So we know bounce equals 0.3214 plus 0.7648 and then drop height. Now let's get back to uh so this is what we got. So you can see, remember, we are always predicting, so the response variable should have a hat. So you can see this is what we got, and then that matches this one here. So that is how to do this. You just have to be quick and start crunch. Let's proceed. So the next one says that we should tell what the residual plot indicates about the appropriateness of the linear model fit to the data that was used to fit the data. So when we see this, what are we seeing? Look at this. You can see that the spread is changing. You see, so you can see the model is not appropriate. We can all see that because we expect that the spread should be even, something like this, So the spread, it's not, and then we can also see that the spread is what changing. So that is how to answer that problem. Let's proceed here. So here, which of the following scatter plot of residual suggests that linear model may not be applicable? So all they are trying to ask is that which of these scatter plots of the residuals shows that the linear model may not be appropriate. So what can we see? This looks okay, but this is looking like this. I don't know, but yeah. So that is one. And then this also looks okay. This is also not okay because this is also looking like this. You see? So it's very easy to spot them because we don't want stuff like that. So it shows that the linear model is not appropriate. And so we can see the correct answer is what? I and then IV. Now let's proceed. Okay, let's solve this problem here. So let's do the first one. We are told that an imaginary poll in January 2005 asked 1,231 US adults how likely they were to see a new movie, right? How likely they were to see a new movie that would be coming out in the summer. So we have this table here, and then we are told that let's call someone who responded, they will definitely or probably see it a likely viewer. So let's try to do that. So let's do likely viewer. So likely viewer is going to be what? 219 plus 271. That is what they said because they said somebody who would definitely or probably see it. Definitely or probably. So these two people are called likely viewer. And so when you add these two, what do you get? You get 490. Okay. And then the other two categories unlikely viewer. So let's do that. So that is going to be 347 plus 394. So let's do that on our calculators. That is 743. 347 plus 394. It's 741 instead. So this is 741. Yeah. And so now the problem, so we have those likely viewers and then the unlikely viewers. The question is that if we select two people at random from the sample, what is the probability the that both are likely viewers? So if we select two people, what is the probability that both are likely viewers? So to be able to do that, what the probability of being a likely, so the first person will be a likely viewer. So if you're a likely viewer, that's going to be what? 490 divided by 1231. That's for the person. And the second person, and 490 divided by 1231. So when you do this, you should get 0.158. So that is how to answer that. Now let's proceed to the next one. For this, it says that you draw a card at random from a standard deck of 52 cards. Find the probability that the card is a face card given that it is a king. How do we answer this problem? Let's try to do it. So to answer that problem, we are looking for what? What are we looking for? We are looking for probability of what? Face card, right? Given that it is a king. That is what we are looking for. Okay. We know this by definition is going to be probability of what? Face card and a king divided by probability of a king, isn't it? Okay. So let's do them separately. What is the probability of being a king? How many kings do we have? We have four of them. So that is 4 over 52. Okay. Probability of what? Face card and a king. So this means that we have 12 face cards, but we are interested in face card and a king. So it has to satisfy both conditions. So how many face cards are kings? That's also four of them. So then this gives us 4 divided by 52 divided by 4 divided by 52. This cancels everything here. And so that is what? 1. So that is how to answer that. And so in this problem here, we are told that a newspaper randomly sampled households by telephone during various times of the day. The people sampled are within the newspaper's distribution. The newspaper reporter asked, are you patriotic in a time of war or armed conflict? And so I'm sure that if they ask all of you now that are you patriotic or armed conflict, in a time of war or armed conflict? I'm sure everybody's going to say yes, because everybody loves the country and everybody is willing to do all they can to help the country progress. But the reality is that when the reality hits the gun and you see those bombs and stuffs, I'm sure some people might change their minds. And so you can see there's going to be like a response by us. Now, let's get to the next one. So this one, we are told that at a California college, 19% of the students speak Spanish. So P of S is equal to 0.19. Okay. 5% speak French. P of F is equal to 0.05. And 3% speak both languages. So probability for Spanish and French is equal to 0.03. Now, here is a question. A student is chosen at random from the college. What is the probability that a student who speaks French also speak Spanish? You already speak French. What is the probability that you speak French, you also speak Spanish? So this is going to be what? Probability of what? Spanish, given you speak French, because we are told that you already speak French. But I'm looking for those people that who already speak French, and then they so there's a probability of speaking Spanish, given that you speak French. So a student speaks Spanish, given that they already speak French. So this is how it is. So we can see from here, this is going to be probability of both Spanish and French divided by probability of French. So this is 0.03, 0.05. This is 0.60. So A. So the only challenge here is you being able to translate this sentence here into a conditional probability. That is the only tricky part. Okay, let's do this one here. We are told that the American Red Cross says that 45% of the US population has type O. So let's put that here. Type O equals 0.45. Right? A 0.40. Type A. We can see from here. Type O. Type B 11%. And then the rest are type AB. So how do we get that? The rest AB. So it's going to be 1 minus 0.45 plus 0.40 plus 0.11. So what is that going to be? So that is going to be 0.45 plus 0.4 is 0.85 plus 0.11 is 0.96. 1 minus that gives you 0.04. That means these are AB. Now, we are told that among 6 donors, what is the probability that no one is type AB? Among 6 donors. So to be among 6 donors. So what's the probability of you not being a type AB? Is what? We just add this one plus this plus that. So not, so let's do it here. Not type AB is equal to 0.96. And we are told that among 6 donors. So you're not type AB, you're not type AB, you're not type AB, you're not type AB. So that's going to be what? 0.96 all power what? 6. Or you could multiply. The first person not the type A, B 0.96, second person not type B 0.96 times 0.96 again. You are going to do that. You are going to multiply 0.96 6 times. It's the same as this. This gives you 0.782. 82 something. So you just have to do that. And then we have this one here. Okay. Now, let's do this one. We are told that the independent random variables with the means and the standard deviation, we are asked to find the mean and standard deviation of this 1 to 2 decimal places. So the first thing I would like to do is to write the mean of x. What is mean of x? 130. SD of x is equal to what? 12, which means that var of x is equal to 12 squared, which is equal to 144. Good. Now, mean of y is equal to 300. SD of y is equal to 11. Var of y is equal to 11 squared, which is 121. Now I want the mean and standard deviation of this guy here. So let's do the mean and standard deviation of that. So mean of that. So we have all those properties already. So what is E of x? 130. E of y, 300. This is what? Minus 170. So we are good on that. Okay. Now let's find the standard deviation. To find the standard deviation, let's find the variance first. So variance of x minus y, based on the properties we learned, there's the same thing as what? Let me bring it somewhere here. There's the same thing as what? Var of x plus, even though here is minus, you just have to be careful. Plus var of y. But when here is minus, it's still minus. So just be careful on that. What is variance of x? 144 plus what is variance of y? 121. So var of x minus y is 144 plus 121. Let's try to do that. 265. But we want the standard deviation. So SD is equal to always square root of the variance. SD is equal to square root of 265. And so that is 16.2788. So 16.28. Now, I have an advice for you. So sometimes, well, it's the same thing. Sometimes when you look at this one here to eliminate, like if you're working at a time, do the variance first. And when you get this, you can see that all these three are eliminated. Right. And then now you can do the mean. And then you're just left within these two. So it's the same. But I think that one might save you time. Okay. Let's do this. We are told that we should list the sample space and tell whether the events are equally likely. Okay, let's do that. toss a coin 5 times and record the number of heads. So let's get the sample space first. Sample space. So what are we recording? We are recording the number of heads. We could toss the coin for 5 times and we could get all tails. If we get all tails, it means that we have 0 heads. We could also get 1 head, 2 head, 3 heads, 4 heads, and all the 5 times are going to get 5 heads. So based on this, we can see that this guy is out, out, out. So you're left with this 2. We are just left with B and then E. So how do we determine if the events are equally likely? We've learned that to be able to determine if the events are equally likely, let's look at their probabilities. If their probabilities are the same, it means that the events is equally likely, right? So let's see. To be able to do that, we know that the denominator is going to be the same. What is the probability of you getting 0 heads? So we know it means that there's going to be what? Tail, 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 tail. And so that is going to be what? It's going to occur in what? One way. What's the probability of you getting 3 heads? Probability of you getting 3 is going to occur in 3 ways. What are those 3 ways? First, we could get head, head, tail, head, tail. We could also get head, 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 tail, tail. We could also get tail, head, 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 tail. You see, this is 3 ways. This is one way. This is 3 ways. If the denominators are the same, we can say the probabilities are not going to be the same because this is one. That's going to occur in one way. That's going to occur in what? 3 ways. And so we can see not likely. For them to be likely, it means that the probabilities across all the sample space needs to be the same. So let's proceed. So for this one here, we are asked to find the correlation. So to find the correlation, all we have to do is to go to our stat crunch and then input these figures there and then find the correlation. Let's try to do that. Okay, here is rainfall. And then here is wheat. Yield. And then 11.37.11. And So when you read the problem, it says that scientists collect data to predict wheat yield. So we are predicting wheat yield. So wheat yield is the response variable, that is the y. And then based on rainfall, so the rainfall is the explanatory variable. So we come to start, let's go to regression, simple linear. Our x variable is the rainfall, our y variable is the wheat yield. And then all we need to do is just click compute. And then we asked to find the correlation. Correlation is R. So you see, it's here 0.94, 0.9418, 0.9418. So I think it's 0.942 in the answer. So let's take note of that. And then let's get to the problem. So you see that is 0.942. So you can use StatCrunch to be able to do that. Okay. Now, we asked to use the tree diagram to find the indicated probability. So we are told that 33.4% of population infected with the disease. There is a test for the disease, however, the test is not completely accurate. 93% of those who have the disease will test positive. 3.7 of those who do not have the disease will also test positive. What's the probability that any given person will test positive? So let's try to do that. So I'll do that here. So the first person, 3.4% of the population are infected with a certain disease. So I have this one here. I have this one here. So 3.4% are infected with a certain disease. So those people who are infected, not infected with a certain disease. So here is 0.034. If here is 0.034, what do you think here would be? All you have to do is do 1 minus 0.034. So let's do that on our calculator. That is 0.966. Okay. And then we are done with that. Not infected, infected. There is a test for the disease. However, the test is not completely accurate. 93% of those infected with the disease will test positive. Those infected with the disease, 93% of them will test positive. So test positive, how many of them? 0.93. How many of them will test negative? 0.07 negative. That's what we have. However, 3.7% of those who do not have the disease, so those who are not infected, will test positive. So if you're not infected, but because the test is not accurate, 0.037 of them will test positive, and then it means here is going to be what 0.0963 will test negative. Okay, so that is how to show that on a tree diagram. What is the probability that any given person will test positive? So to find that probability, it's just going to be, so you have the disease and then you test positive, 0.034 times 0.93, or you don't have the disease but you test positive, so that's false positive, 0.966 times 0.037. So that is just how to do that. And then when you do this, you get 0.06736, which is E. Okay, let's proceed. So here it says that a study shows that the amount of chocolate consumed in Canada and the number of automobile accidents is positively related. Okay, find the Likert variable if there is one. So first we need to understand what a Likert variable is. So a Likert variable is a hidden or unobserved variable that affects the relationship between two variables but is not included in the analysis. So when we look through this problem, there is a Likert variable, and then because it's positive, it means that as the number of chocolates consumed increases, automobile accident increases, and the Likert variable could be population growth. Because as the population is also increasing, people are consuming more chocolate, there's going to be more accidents. So, but it's not factored in this too. So that is the Likert variable. So I will end here and then do the final part. So I'll see you in the final